Review paper on the study of perforated concrete pavement. Abstract permeable pavement typically consists of pervious concrete, porous asphalt, permeable interlocking concrete paving units or grid-type system over an open graded sub-base layer. Permeable pavement infiltrate storm water, reduce peak flow, filter and clean contaminant and promote groundwater recharge. They have gained substantial popularity in North America and have become an integral part of low-impact design and best management practices for storm water management. In order to be effective, permeable pavement must be designed to provide sufficient structural capacity to accommodate the anticipated vehicle loading, manage storm water flow into the surface and soil subgrade, as well water draining out of the base/subbase. While there are many well-designed and constructed permeable pavement, they are a relatively new technology with some projects performing below design expectation. This paper describes some essential best practices for permeable pave design and construction, and focuses on lesson learned from case studies of permeable pavement construction in North America. Keyword: perforated concrete, stormwater, runoff management, rural area, urban area. Introduction. Pervious cement is blend of rock, concrete, water, practically zero sand, fine total, with or without admixtures. At the point when pervious concrete is utilized for clearing the open cell structures permits the storm water to channel through the asphalt and into the basic soils. We can likewise say that pervious solid aids in securing the outside of the asphalt and its condition. Pervious asphalt go about as both an asphalt and tempest water the board device. The total is for the most part of a solitary size and is limited mutually in a concrete glue. Utilizing adequate glue to cover and tie the total particles together makes high porous framework with interconnected voids which depletes rapidly. We can be likewise given a punctured channel to gather it and channels to the required treatment plant. Pervious concrete can be used for a number of application, but it is primary use in road pavement such as rural areas. This report will focus on the pavement application of the concrete, which also has been referred to as porous concrete, permeable concrete, no fines concrete, porosity concrete. Pervious concrete is zero slump open graded material consisting of cement, coarse aggregate of cement, coarse aggregate admixture and water. Pervious concrete contain little or no fines aggregate such as sand. It is sometimes used as non-fines concrete. Pervious concrete are designed to achieve water quality and quantity benefits by allowing movement of storm water through the pavement surface and into a base/subbase reservoir. The water passes through the voids in the pavement material and provides the structural support conventional pavement. That's why pervious pavement can be served as an alternative to conventional road and parking lots. This pavement have ability to reduce urban runoff and trap pollution. Also, it provides opportunities to reduce the impact of urbanization on the management of storm water. 2. Literature Review Survey. 1. Mr. Goravutamshinda and Drive SS Valanjakar in 2015, in this paper intentional on cost and time control in storm water management using pervious concrete. They study the pervious concrete in metro cities and the previous concrete has introduced in metro cities as a road pavement material. They said that, in metro city pavement pervious concrete is new concept because of problems in urban area related to low groundwater table and storm water management. In this paper one case study is analyzed. Considering rainfall data, traffic volume data, soil and geotechnical investigation data of a residential colony which was taken as a part of a case study, the suitability of a previous concrete was checked. Cost comparison between conventional method of storm water management and storm water management using previous concrete pavement is checked. This paper states that, in metro cities cost consideration is the primary factor. Maintenance of costly storm water management system is difficult to execute in cities due to its large population. They also states that, previous concrete pavement is irreplaceable and effective means to meet growing environment and population demand. 2. Jan Athul Thasna. P. Jawahar Sharif, 2018, in this paper has summarized research on water absorbing pavement by the porous concrete, they discuss about the solution for low groundwater level, agriculture problem, management of storm water runoff. Application and engineering property of porous concrete are discussed. They also studied about material of porous pavement such as cement, aggregates, water, admixture, and etc. Benefit, advantage, and disadvantage, durability, strength of porous concrete are also highlighted. In this paper they discourse about replacement of cement by fly ash, which result is safe disposal, safe material in porous concrete, hence it acts eco-friendly paving pavement. 3. Jayeshkumar Petroda and J. Bobsar in 2013, they have studied that on rural area. They said that, perforated concrete is a relatively new concept for rural road pavement. With increase into the groundwater level, agriculture problems. The previous concrete is used as paving material. They states that, in the rural area, cost consideration is very important factor which must be kept in mind. So that in rural areas costly storm water management practices is not applicable. They conclude that is to capture the rainwater and allowing it to seep into the ground. This pavement technology creates more efficient land use by eliminating the need for relation ponds, swell and other costly storm water management devices. 4. Mosud Kahanan, Hwaley, and John T. Harvey in 2019. They considered that on the perforated pavement in highways for storm water runoff management and pollution prevention. They have discussed and summarized the major findings of these collective studies related to hydraulic performance evaluation of permeable pavement, permeability measurement of porous asphalt and previous concrete paved surfaces, clogging evaluation of permeable pavement surfaces, and water quality and pollution control issues. They said that in the future, permeable pavements including the full-depth permeable pavement, FDPP, will be part of an integrated sustainable transportation program. They states that, if FDPP designed properly, it can be used as an alternative best management practice, BMP, for storm water runoff management. They states that the specific characteristics of FDPP throughout the life of pavements. Surface pavement remain highly permeable and unclogged, allowing minimum permeability of subgrade soil to infiltrate the captured runoff, assuming no adverse impact on underground water. 5. Sarabwaikale, Amit P. Halwil superscript 2, Kartik Rathod superscript 3, Mayur Ajirapur in 2017, they perform the research on permeable pavement system and their uses. In this paper, they studied about permeable pavement system, sustainable drainage system, porous pavement, storm water, sustainability, filtration, drain, geothermal heating and cooling. Water quality control and maintenance are highlighted, deliberated about recent innovation, advantage and disadvantages in this paper. They concentrated on the use of permeable pavement in sustainable urban drainage system. The motto of this paper is to show the application of permeable pavement in drainage system. 6. Vikram 1, Mela RP in 2015, in this paper, different blend extents were set up by supplanting concrete with silica rage, 6%, and expansion of superplasticizers, 0.13 to 0.25%, with fluctuating size of total, 4.75 to 20, have been utilized for examining properties of new and solidify Pervious cement. W/C proportion kept steady 0.34. Various properties of Pervious cement: example functionality, compressive quality, split rigidity, flexural quality T7, 28, 56 days and bond quality at 28 and 56 days have been concentrated tentatively. Results indicated that quality of Pervious cement is diminished with expansion of silica flume and superplastizers. The blend extent in with total size, 4.75 to 10 mm, invigorates better contrasted with 10 to 20 mm, and 4.75 to 20 mm. 7.A.M. Admire, A.V. Gandhi, S.S. Adsal, A.A. Agrukar. G. S. Bhor, G.P. Colt, has summarized literature on permeable pavements. Also describe about the permissible pavement, their types in which pervious concrete is most common today. They had also described about the needs and applications of previous pavement, their lifespan, that how long its life will be, the water quality which pass through pavement. They have also discussed about the future scope and research. 8. Javier Castro, Graduate Research Assistant, in 2010. In this paper states an experimental study on transport properties of concrete are controlled by the characteristics of its pore network. Total porosity, pore size, pore connectivity, and pore saturation all influence the measured transport coefficients. Garbachi 1990, Benz et al. 1999. Considerable research has been based on environmentally sustainable development. This has mainly to the use of pervious concrete in place of conventional concrete. Pervious concrete has been used as an effective method for handling and reducing negative environmental impacts. The voids are creates in the concrete for passing the water from concrete, also reducing the problem of water logging and make a road surface skid resistance and increasing the water table. The performance of pervious concrete was compared with the material used for the construction of concrete road pavements. The tests were conducted to determine the properties of concrete like compression strength, flexural strength, and also permeability of concrete. It was found that pervious concrete pavements possesses some positive features like increased skid resistance and high permeability, but most importantly it requires the high strength for highly trafficked areas. Pervious concrete has proven to have properties suitable for use in low volume traffic areas. If pervious concrete pavements can be implemented, it will have various positive effects on the environment. 9. Dr. M. Majeswari, M. P. Karthikeyan, S. Pavitran, M. Rajkumar and R. Govindrajan, 2016, stated areas follow. Purpose: collects the water stored in concrete and drains it to the required treatment plant or a recharge pit. Design: different combinations of cement, GGBS, water, and coarse aggregate with different maximum size and gradation were adopted for trial mixes to arrive at M20 grade concrete. M20 grade concrete is achieved with a W/C ratio of 0.36, coarse aggregate of nominal size 20 mm past and 10 mm retained cement is partly replaced with 30% of GGBS and with a cement to coarse aggregate ratio of 1:4. Its compressive strength were observed to be 20.4 knots per cubic meter. A perforated pipe can be provided at center of the pavement above sub-base. 10. Mohammed Sonbia, Mohammed Baswanab, Amr Yayasan 2016 states that, in this paper for many years, Portland cement pervious concrete, PCPC, has been making an important contribution, as a sustainable urban drainage system, SUDS, in particular, on improving environmental conditions. This type of porous concrete can help minimizing flooding risks, recharging groundwater table, reducing runoff and peak flows, and improving water quality. In addition, PCPC can be reduce the absorption of solar radiation power and urban heat storage potential, which can lead to temperate urban conditions, in which protecting the environment and health and safety of living things. This increase of impervious surface areas, which block the percolation of precipitation from rainfall and snow down through the ground. This increases the potential for excess surface runoff, which can lead to downstream flooding, bank and control the pollution. 3. Material. Cement. Evaluation: OPC gives high quality and sturdiness to structure in light of its ideal molecule size, conveyance and prevalent crystallized structure. Being a high-quality concrete, it gives various preferences. Any place cement to unique high-quality application is required, for example, in the development of high-rises, spans, flyovers, fireplaces, runways, solid streets and other overwhelming burden-bearing structures. Coarse aggregate. Coarse total was utilized as an essential fixing in making the penetrable cement. Bigger totals give a more unpleasant surface. Ongoing utilizations for pervious cement have concentrated on parking garages, low-traffic asphalts, and walkways. For these applications, the littlest estimated total attainable is utilized for stylish reasons. Coarse totals are those that are held on the sifter of work size 4.75 mm. Their upper size is by and large around 7.5 mm. Rock from waterway bed are the best coarse totals, really taking shape of regular cement. Water. Water to cementitious materials proportions between 0.34 and 0.40 are utilized routinely with appropriate incorporation of compound admixtures, and those as high as 0.45 and 0.52 have been utilized effectively. The connection among quality and water to cementitious materials proportion isn't clear for pervious cement on the grounds that not at all like ordinary cement, the all-out glue content is not exactly the voids content between the totals. Admixtures. Compound admixtures are utilized in pervious cement to acquire unique properties, as in regular cement. Due to the quick setting time related with pervious solid, retarders, or hydration settling admixtures are utilized normally. Here we utilized two distinct admixtures, for example, fly debris and compost 500. Fly debris, the consuming of harder, more established anthracite and bituminous coal ordinarily creates class F fly debris. This fly debris is pozzolanic in nature, and contains under 20% lime, CaO. It is a fine powder which is result from consuming pounded coal in electric age power plants, and it is a pozzolan, a substance containing aluminous and silicious materials that structures concrete within the site of water. Class F fly debris, with particles shrouded in a sort of liquefied glass, enormously diminishes the danger of extension because of sulfate assault, as may happen in treated soils or close to waterfront areas. Compost SP500. Compost SP500 consents to IS 9103:199 and BS 5075 Section 3. Compost SP500 fits in with ASTM C494 Sort G. It is the elite water lessening and superplasticizing admixture. Compost SP500 depends on sulfonated naphthalene polymers and is provided as an earthy colored fluid in a split-second dispersible in water. Compost SP500 has been uniquely detailed to give high water decreases up to 25% without loss of usefulness or to create excellent cement. The fundamental preferences of this admixture are improved functionality, expanded quality, improved quality, higher attachment, and chloride-free.